Invisible, powerful, and all around us, radiation is a force of nature that shapes our world in ways we barely notice. From the warmth of the sun to the energy inside nuclear reactors, radiation is both a source of life and a force of destruction. But what really happens when atoms break down? What is radioactive decay, and why does it matter? In this video we will learn about what is radiation, what is radioactive decay, and what is annihilation. What is the atom? Atoms are the basic particles of the chemical elements. Atoms combine to form molecules and make up all matter in the universe. The number of protons in an atom, its atomic number, determines what element it is, e.g. hydrogen has 1 proton, oxygen has 8. Atomic number and mass number. The atomic number is the number of protons, defines the element. The mass number is the sum of protons and neutrons. Atoms of the same element can have different numbers of neutrons, leading to the concept of isotopes. Some of these isotopes are unstable and undergo radioactive decay, releasing energy and particles. What does an atom contain? The basic structure of an atom, which contains the nucleus, protons, neutrons, electrons, and orbits. Nucleus. At the center of the atom lies the nucleus, depicted as a cluster of red and blue spheres. The nucleus is the dense, positively charged core of the atom. Protons. Within the nucleus, the red spheres represent protons. Protons are positively charged particles that determine the atomic number of an element. Neutron, also found in the nucleus, are neutrons, represented by the blue spheres. Neutrons are neutral particles, meaning they carry no charge. Together with protons, they contribute to the atom's mass. Electron. The green spheres orbiting the nucleus represent electrons. Electrons are negatively charged particles that are much smaller than protons and neutrons. Orbit. The thin, gray, elliptical paths around the nucleus depict the electron orbits. These orbits are not fixed paths but rather represent regions where electrons are most likely to be found. So what is radiation? Radiation is called energy in motion. Radiation is the form of energy which moves from one place to another in the form of waves or particles. The unit used to measure radiation is known as sievert, SV. Radiation is of two types: particle radiation, also called particulate radiation. Electromagnetic radiation, also called simply radiation. What is radioactive decay? Radioactive decay. It is the process by which an unstable atomic nucleus loses energy by emitting radiation. This happens when an atom has too many or too few neutrons, making it unstable. To become more stable, it breaks down by releasing particles and energy in different forms. There are 3 main types of radioactive decay: alpha decay, beta decay, gamma decay. Alpha decay. Alpha decay is a type of radioactive decay where an unstable nucleus releases an alpha particle, alpha, to become more stable. This process decreases both the atomic number and mass number of the atom. Alpha decay process. When an atom undergoes alpha decay, the following changes occur: the atomic number decreases by 2, because 2 protons are lost. The mass number decreases by 4, because 2 protons plus 2 neutrons are lost. A new element is formed. Example: uranium-238, superscript 2 superscript 3U, undergoing alpha decay. Uranium-238 emits an alpha particle and turns into thorium-234. Beta decay. Beta decay is a type of radioactive decay in which an unstable nucleus transforms into a more stable one by emitting a beta particle, beta. This process changes the number of protons and neutrons in the nucleus, leading to the formation of a new element. Penetration power, medium, stopped by plastic or glass. Beta decay process. Beta decay occurs when an unstable nucleus transforms by converting one of its subatomic particles, releasing a beta particle, beta, and other radiation. This process helps the nucleus become more stable. There are 2 types of beta decay: beta- decay. Beta decay, an electron, beta, is emitted. Beta plus decay, a positron, beta, is emitted. Gamma decay. Gamma decay is a type of radioactive decay where an unstable nucleus releases high-energy electromagnetic waves called gamma rays, gamma, to become more stable. Unlike alpha and beta decay, gamma decay does not change the number of protons or neutrons in the nucleus, it only releases excess energy. Penetration power, high, requires lead or thick concrete to block. Gamma decay process occurs when a nucleus is in an excited, high-energy state after alpha or beta decay. Why? The nucleus wants to become more stable by releasing extra energy. Steps: a nucleus emits a gamma photon, gamma ray, to release excess energy. The element remains the same, but the nucleus moves to a lower energy state. Example: cobalt-60, Co, gamma decay. Cobalt-60 first undergoes beta decay, turning into nickel-60, which is left in an excited state. It then releases gamma rays to return to a stable state. The annihilation: when a positron, a positively charged electron, and an electron collide and annihilate each other, their mass is converted into energy, typically producing two gamma-ray photons, each with an energy of approximately 511 keV, kilo-electronvolts. The annihilation process: 1. Electron-positron collision. A positron, E plus E caret plus E plus, the antimatter counterpart of an electron, interacts with a free electron, E minus E caret E minus. The two particles combine and annihilate each other. 2. Gamma-ray emission. The total mass of both particles is converted into energy via Einstein's equation, E equals mc2 E equals mc caret 2 E equals mc2. Two gamma-ray photons, gamma rays, are produced, each with an energy of 511 keV, kilo-electronvolts. These photons travel in opposite directions, 180 degrees apart, to conserve momentum. If you found this video interesting, don't forget to hit that like button, subscribe for more content, and drop a comment below with your thoughts or questions. I'd love to hear what you think. And remember, science isn't just about knowing facts, it's about staying curious. Thanks for watching, this is Shady signing off and I'll see you in the next one.